All right, assignment 5-4. For problems 1 to 2, change each one to a logarithm. Easy peasy. Start with the exponent. The base of a logarithm has a base of e is ln, and then what goes inside is 17. Oops, I almost didn't make it easy. Again here, the other way, what's inside the logarithm? The base you don't see for a common logarithm is 10, and the exponent is -2. I don't want you to write in your book. I want this in your notebook, but I'm doing it in the book, just because. I'll simplify each one. The exponent is in front. Ln e, base e, simplifies to 1, and so the answer is a plus b. 3 with a base of 3, so you have a base and another base, they cross out, so the answer is just m squared. Number 5. Solve for x without using a calculator. 2 to the exponent 3 is 8. A base to the exponent 3 is 64. That's because 4 cubed is 64. All right, I'm going to need a little room for this one. Where did my papers go? Number 7. All right, I want to sketch a graph of this. So for a logarithm, it goes through the point 1, 0, and then the asymptote. So the asymptote is at x equals 0, and the intercept is at 1, 0. Number 8. The same graph, but everything's been shifted to the left 3. And now the asymptote is at -3, and the intercept's at -2. So I just took this whole graph and shifted it to the left 3. Number 9, absolute value. So I'm going to take the above graph that I just did, the absolute value. Normally you can't have a negative number inside a logarithm, so all of this would be empty, but the absolute value makes it positive. I take this graph and I reflect it over to the other side. That's what the absolute value bars does. It does a reflection. And so this is reflected. 0 still is the only number that doesn't work. And so we have intercepts at both positive and -1 now. Number 10. Oh, wait a second. I just wrote number 10. This is number 10. Number 9 is this. What would that graph look like? So if I take the same graph here, what's negative just gets reflected up and becomes positive. So that part's the same, but this part that would come up is now reflected up and does this. So there's number 9. And then I did number 10 here. Number 11. Properties of logarithms. Oops. So when you're dividing, you're subtracting. When you're multiplying, you're adding. We need parentheses because that means both belong in the denominator. Number 12. Properties of logarithms, when you're multiplying, you add, and then the exponent for y gets written in front as a product. Number 13, the other direction. It's expanded. Can you write this as a 1 logarithm? So the 3 is the exponent for x. Subtracting means dividing. 1/2 is the exponent, and the exponent 1/2 means square root. Done. Number 14. So to write this as 1 logarithm, we have a divided by b squared divided by c. We could multiply by the reciprocal, and then the reciprocal would make a times c would be in the numerator. But this is a good answer too. Number 15. Ln and e cancel each other out, leaves me just with t squared subtract t equals 6. I need to be a little bit careful here. Well, actually, this will always be a positive value, so I don't have to be careful. All right. Factor it and then solve it. That's positive 3 and negative 2. Number 16. Without a calculator, I have to leave e logarithm in the answer. So I'll show you. Add 3 to the other side. Write this as a logarithm. It's an e, isn't it? So the base of e is ln and 3, and then get t by itself. So I'm going to add 1 and then divide everything by 2. Number 17. Now I get to use a calculator. Well, if I'm going to use a calculator, I'm going to use a calculator. Like, I'm not doing any work. Like, I'm just going to type that in. So type it in. So to remind yourself how to solve with your calculator, you press menu, then algebra, and then solve. Type it in, but then you have to go comma x at the end and see if you get the same answer I get. If you do it properly, x is equal to 0.552. And the other answer is 1.963. So again, use your calculator. Make sure you go comma x after solve, and that's what you put in. And see if you got the same answer. Number 18. How do I do a log? With this calculator, you just type in log in the numbers. You don't have to change the base. So where's that button? So look here. See that above the 10 to the x. See the log button in blue? I know it's blurry. See the log button in blue? So press Control and then 10 to the x. And then once you have a logarithm, then you just type it in. So the base is 3, and then 20, and that's it. So 2.727. (19) Use a first derivative number line to determine whether or not this is monotonic. Is it only increasing or decreasing? So we do the derivative. I'm going to divide everything by 3. and then I'm going to factor it. So when I factor it, the answer is 3. This is going to be monotonic. That's the critical number. Whatever number I plug into the derivative, the answer, because you're squaring, is always positive. So this is strictly increasing. So yes, 1 to 1. Mono means 1, right? So 1 sign. Number 20. We're rolling along here. Now just practicing derivatives. This is easy stuff here. Step 1 here. Use a property. Step 2. The derivative of ln x, and you have your answer. 21. So the derivative of ln x is 1 over x. That's the heart of the lesson. So what's the derivative rule for ln? You draw a fraction, you copy in the denominator, and then the derivative goes in the numerator. The absolute value bars do not change the rule. The rule stays the same. So the derivative here, draw a fraction line. Remember to press pause if it's going too fast. What you see goes in the denominator. The derivative goes in the numerator. Press pause. Try number 23, then press play. All right, this is actually a power rule, so the power is 4. So we multiply by 4, subtract 1, and then the hook is the derivative of the base. 24. I'm going to write it calculus friendly right away. We're going to do a property. And then the derivative. So it's 1/2, and then the denominator, and then the derivative goes in the numerator. Done. 25. Again, press pause and do it first, then play. Again, the absolute value bars do not change the rule. So what I see is x squared minus 1. The derivative is 2x. The base is not e, so I need a ln 5 with the rule, and it's over. 26. Press pause and think about it. This is the product rule. The first times the derivative of the second plus the second times the derivative of the first. 27. Press pause. Step 1 is to use properties. So when you're dividing, you subtract. And then one more property, the 2 can be written in front of the logarithm. And now we're at a point where we can take the derivative. So again, what I see and the derivative in the numerator. You could also write this as 2 over x. 28. This is going to be the quotient rule. That's the bottom times the derivative of the top minus the top times the derivative of the bottom, and then the bottom squared. This is just 1. To be ln t, take away 1 over ln t squared. Make sure you use the bars. So when it says the bottom, make sure the bars are included. 29. All right, here we go. The derivative of this, the derivative of a logarithm, what's inside the logarithm is a logarithm. And then the derivative of this goes in the numerator. You could also write it like this. Both are good. Good answers. Number 30. Oh, trigonometry. Here we go. So it's a logarithm, so draw a fraction. What you see, cotangent x. The derivative of that, which is negative cosecant squared x. And that's it, right? Or did they try to simplify that? No. 31. This is not a logarithm. So what's the derivative of an exponential? You copy it. And then the derivative of the exponent is the hook. 32. The derivative of this, you copy the hook, and then it needs a ln 5 because the base is not e. Ooh, tricky one. X to the exponent x. Let me just see how they handle this. I think they did a logarithm here. Yeah. So write this as a logarithm. And then change the base using a natural logarithm. Oops, this is log. And then ln y over ln x. And then take the derivative. So this is going to be the product rule. The first times the derivative of the second plus the second times the derivative of the first, which is 1. This is going to be y and then y prime on top. So then we need to multiply everything times y to get our answer. So x is crossed out. And there's the derivative. Now, if you want it in terms of x, what does y equal? Y equals x to the x. So then we can take out the y and put in x to the x. So now you don't have y in the answer. Because that's what y equals, x to the x. Tricky, right? It's okay. 34. Can I just show you another thing? You could actually do a little bit quicker here. You can do logarithm to both sides to begin with. So ln y, ln x to the x. And then use the property of logarithms to bring it down, that we could get to this step quicker. This is the same as this. But we did it in one step rather than two. So you could also do that. 34. Again, I think I'm going to do a logarithm. So I'm going to do it that way. Ln use a property of logarithms, so the exponent. Now, this is y prime over y. The first times the derivative of the second plus the second times the derivative of the first. And then multiply everything times y. And then we could take out y and put in what y equals, or not, if you want it all in terms of x. Those are tough, right? Not too bad, but a little bit different. 35. So f at x equals ln and the square root of x. Sketch the graph without using a calculator. That's not very nice. Well, I know 0 is no good, and any negative numbers is no good. If I plug in 1, the square root of 1 is 1, so 1 does give me 0. If I plug in 4, ultimately it's going to look the same. It's just going to, the square root is just going to do this. What's going to happen is this. This is that, and then if you write it, you can write the 1/2 in front. So it's ultimately the same as ln x. With the 1/2 just makes it like squashed. It's a vertical compression. So it's a skinnier. It's closer to the x-axis. Draw a tangent line at 1, 0, and then write an equation for it. So x is 1, y is 0. The slope, the derivative of this is 1/2 times 1 over x. So if I plug in 1, the answer is 1/2. So the equation would be 1/2 x minus 1 plus 0. Done. Number 36. All right, we're going to do this implicitly. So the derivative of y squared, and then it needs a y prime. The first times the derivative of the second plus the second times the derivative of the first. I'm going to subtract and then I'm going to factor out. That's 2y subtract x over y. And then divide. Doesn't have to look that pretty. So that kind of, it looks pretty enough to me. Done. $37. So the derivative of x is 1. The derivative of ln, what you see is in the denominator. This is the product rule. That's the first times the derivative of the second minus the, or plus the second times the derivative of the first. And then the derivative of 10 is 0. I'm going to add this whole fraction to the other side. That will make it positive. So I just added that to the other side. I'm going to multiply by xy. I'm going to subtract y and then divide by x and have my answer. $38. Y equals e to the negative 3x over 3 plus 2e to the 2x, and I'm asked to find the second derivative. So the first derivative, I copy it, times the derivative of the exponent, I copy it, times the derivative of the exponent. 1/3 times negative 3 is negative 1, or negative e to the negative 3x. 2 times 2 is 4. All right, now I'm ready for the second derivative. Copy it, times negative 3. Copy it, times 2. Number 39. We have x squared subtract ln x plus 1 equals y squared take away 1 at 0, 1. You're asked to find the tangent normal line. So I need to take the derivative first. That's 2x, x plus 1, 2y, y prime. I'm not going to make it complicated. I'm just going to divide by 2y, and there's the derivative. Now, I'm going to plug in 0, 1. So if x is 0, that leaves me with negative 1. And if y is 1, that leaves me with 2. So I get negative a half. So that means the tangent line is y equals negative a half, x minus 0 plus 1. The normal is the perpendicular. It's the opposite reciprocal. So it's positive 2 with the same thing. Perfect. 40. Find the domain. Let's look at it first. Y equals x take away ln x. Domain, because it's a logarithm, it has to be positive. Extreme points, the derivative. I want you to, we already know x can't equal 0, so that's not the answer. The other answer is positive 1. Gives you that answer. Into the derivative, if I plug in 1/2 and do the reciprocal, it's a negative answer. If I plug in like 5, it's a positive answer. So there's a minimum at 1. Plug 1 in here, and it's 1 take away ln 1. By the way, ln 1 is 0. So this is really 1, 1. Ln 1 is equal to 0. It's a good property to know. So that's 1, 1. That's the minimum. It said to find the point of inflection. So I made it, I took this, calculus friendly. The second derivative is positive x to the negative 2. So the only answer here would, there is no answer here. No number here would make it easier. So there's no point of inflection. But if I did a number line, no matter what number I put in here, the answer is always positive. So it's concave up through the whole thing, and there's no point of inflection. So if I graph this, I'd find 1, 1. That's the minimum. And there's the graph. 41. We're almost done. We're only half an hour in, so we're like in great shape. All right, whenever I have a monomial in the denominator, I want to separate it into fractions. So 1 over e to the 2x is e to the negative 2x. 2 to the ex and so on would be 2. Now, x subtract 2x would be negative x. And then we're going to divide these. So e to the 2x, e to the 2x, they divide out, leave me just with 3. So that's what I'm going to integrate. So the hook comes from here. So I need a negative 2. So I need a negative a half. I'm just going to look at each one separately. E to the negative x needs a negative 1. There's a 2 there, so it becomes negative 2. And then 3, well, I know that. That's just 3x. And now we start with negative a half and copy. The hook gets unhooked. Start with negative 2 and copy. This gets unhooked. And then plus 3x plus c. (42). I'm going to FOIL this. If you FOIL this, you get 4t squared. 2 times 4 is 8, and double it. And then 4 squared is 16. The derivative of this is 8t plus 16. So what it was over what it became 8, right, is the difference if you multiply by 8. So it needs a 1/8. That way if you distribute, it stays the same. So it needs a 1/8. It was a 1 and it became an 8. The hook goes away. We start with 1/8, and then e as you copy it. (43). In 43, you have a function. And asked to find the derivative of the inverse at negative 2. So we're going to work backwards. It's nice to have a chart. We have f of x. We have the inverse of f of x. And then the derivatives. Of each one. So what I do know is the inverse is negative 2. And that's what I'm looking for. That means the y value here is negative 2, so we're going to make it equal to negative 2. And solve it. If I plug in, I'm just looking at it. If I plug in negative 1, that's negative 2, negative 1, that's negative 3 plus 1, and it works. I just guessed. You could also use a calculator. Next, I need to take the derivative. And plug in negative 1. These are even exponents, so negative 1 is just 10 plus 3. So my answer is going to be the reciprocal of that. So the answer is 1 over 13. Number 44. I'm just going to make my life easier, I'm going to say the inverse of f at x is just g at x. So this is really just the derivative of g at 2. So if I make this calculus friendly, I'm going to make it equal to 2. And then solve it. So I know the square root of 4 is 2, so x must be 8 for it to give the right answer. And so if I take the derivative, I get 1/2 to the negative 1/2. Take the derivative at 8. So this is 4. The square root of 4, which is 2, and then the reciprocal. That's 1/4. So therefore the reciprocal of that is what I'm looking for. So the answer is 4. 45. These are often really good review questions that you shouldn't whatever. These are really important. Okay, very popular question. This is linearization. Can you do a tangent line and then plug this into the tangent line to approximate it? So for a tangent line, we need x and y, and the slope is the derivative there, which is -3. So the tangent line would be -3, x subtract 4, plus 7. Then, to approximate it, I'm going to plug 4 and 1/3 into the tangent line, and then answer it. So 4 and 1/3, take away 4 is 1/3. 3 times 1/3 leaves me with -1. Oops. And then -1 plus 7. The approximate answer is 6. All right, 2 left. Oh, fun. So a related rate question. We can do this. So a tank shown at the right has a hole in the bottom. It's leaking. Find the rate of change of the height of the water when the height is 4 feet. And it says this is the volume. So it's leaking from the bottom. So we need to find a relationship between the radius and the height. So the radius is 5 and the height is 10. So the relationship there is the radius is always half the height. So when I plug in here, it's half the height. We need one variable. So 1/2 squared is 1/4, and then h squared times h is h cubed. 1/4 and 1/3 is 1/12. And now take the derivative with respect to time. So 3 times this is 3/12, or 4. It needs a dh by dt. Subtract 1 to the exponent. The volume it says leaking at a rate of 1 cubic feet per minute. So the volume is leaking, it's losing, so it's -1. The height is 4, and I'm looking for this. 16 divided by 4 is 4, and then divide and you have your answer. And that would be feet per minute. So the height, the rate of the height per minute as it's leaking, the height is losing that much feet per minute with that rate. 47, last one. I'm going to do it right here. Why not? Use the graph of the derivative shown at the right to graph the second derivative and a possible graph of the function. It's been a while. Let's do it. So we're going to do a number line here. So I notice here Are those ends? Those are ends, right? So negative 2 and 4. Notice the derivative never equals 0, so the derivative is always positive. For the second derivative, it rises up to 0. Then it's flat. And then at 2 and on, it falls. And so we have this is really 0, and then the negative. So we're going to graph that. So for the second derivative, I need to go from negative 2 to 4. So we know at 0 to 2, it's 0. The second derivative is the derivative of this, so the slope of that is positive 1. So from negative 2 to here, it's positive 1. And then this slope is negative 1. So this shows the slope is 1, the slope is 0, the slope is negative 1. The slope is 1, the slope is 0, the slope is negative 1. That's what that shows. The function the whole function is rising, and it goes concave up, and then a line, and then concave down. And there's no starting point, right? So wherever. So from negative 2 to 0, it rises and it's concave up. And then from 0 to 2, it's a line and still rising with no concavity. And then from 2 to 4, it's still rising, but now it's concave down. And there's the graph. All right. I'm super proud of you. Mr. G Math over and out. Till next time.